Welcome to this explainer. If you've spent any time poking around C code bases, you've definitely bumped into function-like macros. They look like functions, they kind of act like functions, but beneath the surface, they operate on a completely different set of rules. So today, we're pulling back the curtain on C macros, uncovering their hidden dangers, and learning how to wield them safely. What exactly are we dealing with here? Take a look at this. It's a beautifully simple piece of code, right? This little function-like macro holds immense power and is basically the bedrock of some of the biggest, most robust C code bases out there. But, as we'll see as we go along, it's totally a double-edged sword that requires some very careful handling. To understand why, you gotta meet the preprocessor robot. When you write a simple command in your code, say min5,3, this invisible robot just blindly swaps your text around before the C compiler even wakes up. Seriously, it's just shuffling characters on a page, kind of like a really fast find and replace in a Word document. So the formal definition here is that the preprocessor robot is a distinct phase executing blind text replacement via the #define directive. Just keep this robot metaphor in your head for the rest of this explainer. It obeys your commands instantly, sure, but it is completely blind to C's syntax, types, or logic. To the robot, numbers aren't numbers, they're literally just text. So, if this robot is completely blind, why do we use it so much? Well, it boils down to three massive benefits: unparalleled speed, incredible flexibility, and sheer coding convenience. It's kind of the holy trinity of writing efficient code. And as we can see here, the perks are undeniable. For speed, there is zero function call overhead. Like a macro is actually faster than a normal function because the code is physically injected right where you need it. Then there's flexibility. It handles any data type instantly, whether you're tossing it an int or a float without having to rewrite the function. And convenience, it gives you these awesome, highly readable shortcuts for those small, repetitive tasks. But of course, every powerful tool has its dark side. Let's hit part 3, the 3 big problems. All right, here is where the trap is set. Because this text swap happens entirely in the preprocessor phase, the highly intelligent C compiler never actually sees your original macro. It only ever sees the text the robot left behind. So if the robot makes a mess, the compiler just tries to compile the mess, which leads to some absolutely baffling error messages. You might be thinking, hey, it's just copy and paste. What could possibly go wrong? Well, let's look at the catastrophic bugs this blind text replacement can trigger if you let your guard down. First up, problem number 1, multiple evaluation. Check out what happens when you pass a function like get_next_num into your macro. If that function has side effects, you're in trouble. Because the macro physically duplicates the text get_next_num, the robot makes your program run that function up to 3 times instead of just twice. Imagine if that function was logging a user in or maybe dispensing cash from an ATM. Doing that 3 times in a row? Total disaster. And it gets worse. Problem 2, the robot will happily mix strings and numbers without a single warning because, remember, there's absolutely zero type checking going on. The compiler might not catch the problem until way later. And problem 3, precedence bugs. Without proper formatting, the basic order of mathematical operations just shatters. Your multiplication and addition get all mixed up, and suddenly your calculations are wildly, dangerously incorrect. So how do we fix this? Luckily, you don't have to ditch macros entirely. Your ultimate defense mechanism is strategically layering your parentheses. Look at this example. By carefully wrapping both the individual parameters, the a and b you see inside, and the entire expression itself in outer parentheses, you essentially put a lock on the precedence order. Now the robot can't accidentally break your math. Seriously, if you take away just one golden rule from this entire explainer, let it be this exact sentence. Always wrap parameters and the whole expression in parentheses. Write it on a sticky note, stick it to your monitor. It will literally save you hours of agonizing debugging. All right, let's step out of theory. Here we have some forensic evidence of these concepts in the wild. This is a complete professional main.c file showing the preprocessor doing its thing. You've got the macro definition up top, debug flags in the middle, and conditional release logic all living happily together. Let's break it down. First off, check out the macro itself. Notice how our safely wrapped max macro smoothly returns the bigger of 2 numbers. And because of those extra sets of parentheses we applied, we're not going to trigger any of those nasty precedence bugs we just talked about. The logic is tight, it's secure, and it's incredibly fast. Next, look at this conditional debugging section. This is such a common and powerful pattern. By using hashtag ifdef if you compile your code with the debug flag, this print statement magically appears. But if you don't, the robot deletes the block entirely. It literally vanishes from the code before compiling. That means zero memory or performance cost in your final build. Pretty cool, right? And finally, release guards. This hashtag ifdef block protects your final builds by hiding specific developer output when the release flag is defined. It's basically the inverse of the debug flag. This is exactly how professionals keep their production code super clean without having to manually hunt down and delete every single print statement before shipping. Okay, let's wrap this up. Let's balance the books and weigh both sides here. On the left, we've got massive advantages, amazing code reusability across headers, zero-cost conditional compilation, and incredibly fast shortcuts. But on the right, you absolutely have to respect the dangers. Code bloat from overusing them, brutal debugging nightmares because the compiler errors don't match your original macro text, and of course, operator precedence breaks like the classic square bug. So I encourage you to open up your own C projects today and take a hard look. Are there hidden traps in your macros just waiting to trigger when someone accidentally passes in a function with side effects? Are you properly teaming the preprocessor or letting that blind robot run wild? And, as modern languages push towards safer architectures that don't even use a preprocessor, it begs a much bigger question. Is the era of the blind robot finally coming to an end? Or will its sheer, raw speed keep it alive for decades to come? Think about that the next time you hit compile.